So I'm going to make the case in this talk that this technology and this approach is a good motivator to think about dealing with these use cases differently. And if you heard my previous talk, you heard me talk about the fact that some people talk about AI and machine learning as a silver bullet is going to solve all your problems, and that's just not the case. So this is kind of what this talk is about, tries to make the case.
AI and machine learning is not a silver bullet?
It's not a silver bullet. Yeah, thank you, Emra. Good question. Yeah. Confidential disclaimer, of course. Roadmap information is all confidential, subject to change. Okay. That's a new slide. I didn't do that slide.
I didn't do it.
Okay. All right. So this is the first slide. You saw this slide on the presentation before. For those of you who weren't here, this is a reference to the Gartner hype cycle. The Gartner hype cycle identifies emerging technologies, and the first thing that happens is marketing takes over, and we have overinflated expectations. But I will tell you, part of the motivation for this talk came from the question that I got asked when I got into this industry in the first place. So I joined Interset, or FileTrek in the day, in 2013, so just over almost 6 years ago. And it was my first foray into security. I came from Cognos, got bought by IBM, so business analytics, reporting software, BI, all that kind of stuff. And so when I first got in and I started to engage with customers, I noticed the question that kept getting asked of me was, okay, great, you've got machine learning. Tell me how you're going to have 0 false positives. And it was very specifically asked that way. It wasn't asked like, what's your false positive rate? Or what's your true positive rate? It was, how are you going to guarantee that you will never show me any false positives ever? Like it was very forceful. And I kind of noticed that trend. And so when I thought about this talk, it was kind of the inspiration for it. And kind of why that was, right? So part of the reason is people have inflated expectations of what AI can do. Now hopefully this is the right deck. Let's see. Yeah, great. So my previous slide didn't have the name there. I was going to ask you to guess who that was, but I guess that's not going to work. So this is Garry Kasparov. If you know Garry Kasparov, he was a grand chess master, and he famously lost to Deep Blue, a computer by IBM, in 1997. There's another really interesting reference in 1997 for another computer or AI-related phenomenon that was popular in the movie. Anyone? Anyone? Yeah. What was that? No, but in 1997. Anyone remember 97? Another machine that... No, not Matrix. Close though, right? No, not the Matrix. Terminator, Skynet, 1997, right? So what's interesting about this is that if you go back and you looked at the headlines, it was pretty alarming. So I couldn't show these images, but if you Google Kasparov 1997 Deep Blue, what you'll find is covers of all the big magazines, Time, Newsweek. The era of the machine is upon us. So basically the hype machine took over, and all of a sudden, computers were on the verge of being human-like. That was kind of the expectation. Now the next slide here shows another example. Here we go. So again, I had a build that was going to have you guess who that was, but this one is closer to home. So this is IBM. Who remembers 2011 when IBM's Watson played Jeopardy? Anyone remember that? Show of hands, a couple. So this was interesting because I worked at IBM at the time. I wasn't on that project. I didn't work for the Watson group at the time, but I was with IBM. But what I vividly remember about this experience is that as soon as it was over, I got a call from my parents. Because if you watched it, if you haven't watched it, it's worth actually Googling it and looking at the YouTube video. What's interesting about this is that the application was built in such a way that it literally answered verbally to questions in the form of a question, just like the other contestants on Jeopardy. So it really felt like you had a machine behaving as a human, right? It would listen to the question and it would give you back an answer just like the other contestants, phrased in the form of a question. So it really sounded human. So right after this, I got a call from my parents. They were nervous because they thought that we were on the verge of, Skynet, becoming true. Like, we're going to get like sentience. Machine's going to become self-aware, launch an attack, all this kind of stuff. So it just inflates the hype machine. So again, people that don't understand the technology can easily get swayed into thinking that we're much closer to machines behaving like humans than we are. But it's not magic. So this, oh, I missed it. So 2 quotes that I wanted to call out. One is our CTO, Stefan, that you saw this morning at the main session. He likes to say, math is magical, but it's not magic, right? Math can do really cool things, but it's just going to do what it's going to do. It's going to count things, and it's going to figure out if something is normal or abnormal, or if it's going to classify things, but it's just math. The other one is also very interesting. It's a friend of mine called Samuel Witherspoon. He's a CEO of a company, a data science company up in Ottawa called Immersive Data Labs. He likes to say artificial intelligence is totally artificial and not very intelligent. And I kind of buy that. There's some really cool applications, but machines lack certain things that humans can do. We'll talk about that in this session. But let's go back to the question that I got asked by customers when I first joined. How can you guarantee me no false positives? And that may be very uncomfortable, as you can imagine, because I'm like, well, I'm going to show you anomalies, but I don't know if they're false positives. You're going to have to apply some human judgment. But the reality is, they're asking that question not because they're trying to put me on the spot, but because they're drowning, right? Security operations are drowning. And so when your people are tasked with responding to alerts, with doing incident response, with kind of taking care of the nitty-gritty, the basic day-to-day operations of re-imaging machines when a piece of malware comes in, doing phishing training, all that kind of stuff, then there's no time to hunt for the unknown threats. There's no time to go digging for that information that might help you find the person that's about to leave the company with your stuff before they leave the company with your stuff. That's a really tough thing to do. And if you don't have the right tools to help, it's going to be even tougher. So that's the reason why they're asking is very, very legitimate. So I'll go over this very quickly, but for those of you who were here last session, I apologize, this is repetitive. But for those who are new, let me just kind of walk through this. So this is a traditional rules-based approach to finding an insider threat. If you think about the example that I provided, if you're looking for someone who's potentially exfiltrating company information for the purpose of stealing it, because they're going to the next job and they want to take it with them, something very common, this is one way that Carnegie Mellon, who famously put together an insider threat program, suggested a use case. So if there's an amount of data being sent outside the organization via email and it exceeds a certain threshold, then send me an alert. It was very common as part of the program, and that's where we got some of the inspiration for the models that we built. But if you look at a real life scenario, if you've got tens of thousands of people in your company, then if you follow that kind of rule with a threshold, you're going to get tons of false positives. And the reality is there are people in your company whose job requires them, rather, to send data outside. So they're going to trigger your use case. So a threshold applied across a population just isn't going to work, because for some people, it's going to be normal for them to do this kind of behavior, while for others it's going to be unusual. How do you differentiate them? Without something smarter than this, you're not going to be able to. So our approach is very different. Like I said, machines can be really good at narrow use cases. They can't apply the kind of human intuition to really provide context and judge, but machines can be really good at doing some very specific things, right? And that's an example. So that use case in our world looks more like this. If there's a person sending an email out and the amount of data is higher than usual, then create a high-risk anomaly alert, right? And then let humans come in and kind of judge whether it's malicious or not. And in this example, what machines can do that humans can't at scale, humans can, but they can't do it at scale, is count the amount of data normally being sent out by each individual person via email on a daily basis, right? So as data comes in through email logs, or it could be endpoint logs for USB saves, could be network logs for access to the web, to web-based storage like Box or Dropbox or those sorts of things. Machines can just tally the amount of data normally being sent out for a given amount of time by each individual user and do it at scale, because the machine doesn't sleep. It's a narrow use case. It's very specific. It doesn't have to apply judgment. It's just going to count things and keep a running tally. So doing that kind of work is great for a machine. It'll tell you if something is weird. It's not going to judge, but it's going to tell you if something is weird, right? Machines are really good at doing that. So who's familiar with the MITRE attack framework?
No.
Awesome. Thanks, Emra. So if you haven't heard of it, I highly recommend going to explore it. I bring that up here because, for me, it's probably the best example of human intuition that I've ever seen. So what is human intuition?
What did you call it?
MITRE, M-I-T-R-E,
Okay.
MITRE, yep. It's called the MITRE attack framework, and it's spelled just like that at the top left. Right. So they're a not-for-profit, and they produce amazing stuff. So
Same company or organization that does CVE, right? Commonwealth.
I believe that's correct. Yeah.
CVE.mitre.org. Is
Yeah.
everyone knows them about?
Yep.
This is their, let's say, second project.
Right. And they've got a third one on the I think, yeah. So what they've done is they identify the questions that we should ask. Machines don't know what questions to ask. Machines can answer questions at scale, specific questions that you want to ask it. But machines don't know what questions to ask. Humans do, because we can take context of things that we've learned in the past, the case studies that we've reviewed, the examples that we've seen, the breaches that we've experienced. That's context, that's intuition that we develop as humans, and we can take these concepts and then apply them in a different circumstance. Machines can't do that. But machines can answer numerical questions really, really quickly and at scale, much better than humans. So this is the whole idea of partnering between humans and machines. So this example, on the MITRE side, right, they've identified the questions that are important to ask, right? What are the attacker's motivations? What are the tactics, and you can see them in black there, the tactics that attackers will use to accomplish their goals. So tactics are those high-level sort of strategies that attackers will use to get inside your organization and to try to cause damage. What methods have been used the most successfully in the past? So again, if you go on the attack framework and you review the documentation, not only will it tell you and describe the tactics and the techniques, but it also gives you examples of the actual events that were seen in the wild, with links to the case studies. It's a brilliant set of documentation, which is unbelievably enlightening, right? And what data sources contain the best coverage for the most stealthy threats? The other thing it has is it has detection methods. So for all of these tactics and the techniques, the methods that have been tried, it'll actually tell you which logs contain the events that you should look for to try to find that specific method. It's absolutely fascinating. And what you'll see, if you read that documentation, is in many cases, it'll tell you that that finding the malicious event can be really hard to do because it's mixed in with millions of other legitimate events. And some of the best examples that I can think of are when you're looking for unusual processes on a workstation. I talked about this in the previous talk as well. The idea is, if you're looking for something for like PSXEC or PowerShell or any of those other types of processes that you know could be used by an attacker to try to do lateral movement, to try to figure out if they can access applications, to try to find them, the ones that are malicious, is really hard because your IT shop, your engineers, will actually use these tools on a regular basis, but those are legitimate. They're using them for legitimate purposes. What you want is you want to find a workstation that's never had PowerShell triggered before, and look at that one. That's what a machine can do. It can quantify how normal or abnormal that specific process is, right? But again, we need to know what question to ask and let the machine answer the question because it can do so at scale. So this is what it does, right? It creates, it profiles a given behavior. As the data comes in, it's not magic if you think about it. As the data comes in, it'll literally just build the counts. It'll build the metrics. It figures out what is it exactly that is normal for me when I do my job to send data via email, or how many login attempts am I making generally? What type of login am I doing? Do I ever log in remotely? Yes or no? Do I VPN in? If so, from which countries? Right? Those are the kinds of things that a machine can answer very quickly and at scale, continuously. But if you try to get humans to do that, you'd have to have like an infinite army to do that. It's not scalable. It's not practical. So the point here is there are things that the machine can do that humans just can't do at scale. And there are things that a machine can't do that a human can do. So the whole idea is when you combine the two, then you've got machine-learned behavioral baselines, right, that are answering questions that humans have been able to formalize because we have that context, we have that experience, we understand what we're looking for. What it does, it gives you more effective threat hunting. It gives you a fighting chance at finding insider threats. It gives you a fighting chance at finding nation-state attackers or motivated attackers, right, to make your SOC that much more effective, that much more efficient. And you can't really see it, but if you look at the attack framework, there's about 220 different methods that are identified. And the ones that you see are darker, that's green. I thought it was me at first, so I was like, maybe I called Siri by mistake. But what it does, it gives you a really good amount of coverage, because a lot of the events that you're looking for are going to be hidden amongst legitimate events. You don't want to waste your time. So if you have threat hunters, if you have people who are tasked with finding insider threats, APTs, targeted attacks, and you think that someone's inside your network, which we all kind of believe someone is, then this kind of approach can really give you a fighting chance at finding these things. So that's my plea. My plea is to build like Kasparov and Centaur chess. If you don't know what Centaur chess is, it's basically that Kasparov determined that a machine and a human working together is still the very best chess player. And they can beat machines that are working alone, and they can beat the best humans working alone. So humans, machines working together are the best chess players. So the analogy is, let's build an army of Centaur threat hunters and find these hidden threats. And I think that is all. Again, I'll make a pitch for my friend Paul, who's sitting behind here. He's giving a session tomorrow morning at 9:20. They'll talk about the kind of threats that we can find with this kind of approach. Highly recommended, real good, real-world stories that kind of put it all together and make it real concrete in the kind of examples, use cases. Any questions? Yes, sir.
If I'm asking something here and address my apologies, but it's more around, you have NIST, you have ISO,
Yeah.
you have MITRE, how would you kind of layer these kind of frameworks or methodologies?
I almost threw my mic down. For those of you who were here last time, it almost kind of happened again. It's not a stall technique, I swear. It's just, I think it just depends on what you're trying to solve, right? That's what I think. I have cursory knowledge of the NIST framework, but I'm very familiar with the MITRE framework. The question was, how do you consolidate different frameworks? Like we have the NIST framework that we use to kind of look at a high level. I think the NIST framework is a higher level framework that gives you sort of a roadmap view on the kinds of things you want to do with your general security operations. Whereas the MITRE framework, I believe, is more aimed at specific types of threats, right? So whereas the NIST framework addresses sort of, risk, governance.
And then this is more tactical.
This is very specific to insider threat or outside targeted attacks, like what I call APTs or advanced persistent threats. Think of a very motivated, well-funded attacker that will find a way in through social engineering, spear phishing, or any other method they're going to use to find a way inside your organization. Once they're inside, how do you find them, right? The MITRE framework, for me, is the best framework if you're trying to address those kinds of use cases. That's kind of my belief. Emra, you know the MITRE framework. Do you have any?
I'll be honest.
I've been researching this for more than 2 years now. People have been coming to me and saying, Emrah, do you have a dog in the race? Like, did you put money to the, like, why are you advocating for them so much? I was trying to starting to question myself, like, maybe I shouldn't believe that too much, but I was always finding myself researching it more and more because they were always finding the right stuff. Whatever new attack, like last week I had one of my pre-sales engineers come to me and say, Emrah, we have found a solution for this. I forgot the exact name now. Let's say WannaCry. It wasn't WannaCry. Let's say Blue Kip. Blue Kip A, Blue Kip B, Blue Kip C. All of them having a very interesting, sexy name. No, we don't need to come up with those names. We are looking at the DNA with this technique. It's like a matrix. If that attacker is using one of those DLL injection, another way to do persistence, to gain persistence on the machine, maybe another way to do exfiltration. It could be WinZip, WinRAR, 7-zip. I'm not going to give, Paul is going to talk about this tomorrow, but I was talking to the SOC Prime CEO. I said, dude, like, I agree with your point. I'm on the same boat, don't get me wrong, but what about exfiltration using a zip file? How would you detect that? Emrah, is that your problem? I said, yes, that's my problem. Like, we cannot detect everything in this MITRE ATT&CK framework. It's not just not helpful. He said, what if I told you you could log WinZip or 7-zip, whatever WinRAR, whatever zip utilities you have, they have a log file, you can have a flex connected for that, and start monitoring those for unusual behavior. It could be a very, let's say if they are expecting large sets of data, there would most likely be RAR, R01, R02, R03. In a regular RARing or zipping environment, you don't get those 10, 1 gig each files, you know? So there are anomalies in everything in life, including zipping files. And that was eye-opening for me. So, and that zipping was in this MITRE framework. On the top right, if you look at it from the top-down approach. So another question is, Emrah, MITRE ATT&CK framework versus the 7-step kill chain. What's the big difference? Almost like Neil's question there. What is the difference between NIST and MITRE? I'm not saying one of them is better than the other. There's a reason why they all exist. But MITRE is tactical enough, high-level enough, yet it also tells you exactly what to look for. It's detailed enough as well. It's granular, atomic enough to give you a surviving chance. If you click on those techniques, I think PowerShell is T1108. Each one of them has a...
You got it memorized. Nice.
And boom. And you go to a web page where they talk about, let's say, PowerShell, why PowerShell is being used by which threat actors, and why those threat actors, I think I looked at it last week, 99, I don't know why it's 99, 99 different references as to how PowerShell is being used.
And those are examples that were observed in the real world.
Exactly. And
Like,
then,
yeah.
if you don't need me to tell you MITRE is famous. Just go to MITRE, just Google it, MITRE ATT&CK. Last year, there was 30 videos in Luxembourg. This year, there was another 30, 1 month ago in Luxembourg. Another version, again this year, in US. So MITRE ATT&CK is becoming the new DEF CON or Black Hat, which is not enough per continent. It is being repeatedly done in the same year in multiple continents. So last year it was Microsoft's principal engineer doing the keynote. He talked about how the Sigma rules. It seems there is this world of MITRE, Sigma, and the MIST circle. Those three things are like three musketeers. I don't know why, who decided on that. But if you open one of them, boom, it has a link to the other. These are the open source new methods of SIM attack finding. If you're into this type of thing, I highly recommend finding the free videos from sans.org. There's these two folks, I forgot his name, but one of them is called Dustin. Just Google SEC 555, SEC 555. It's you don't need that course, it's a course, but SANS is famous for courses, but some of their videos, actually all of their videos are free. 1 hour video on why MITRE is important. And again, this is a small joke, but from the last ATT&CK, they asked all the attendees, what is your top 5 MITRE technique? They picked PowerShell, this. What are the top 5 false positive generating techniques? PowerShell. So PowerShell alone is famous, but it's also a very high false positive rate as well. So there is no silver bullet, yet it is the best defense that we have at this time. One company said, MITRE has 300 techniques in it. Emrah, come on. Like last month, 2 months ago, they added a column. Forget the techniques being added. They added a new column. So now another
New tactic.
techniques
A
came.
new tactic.
Yeah,
New
exactly,
tactic.
that came. And then, like, you will never catch up with this, let's just be honest. The moment we catch up, there will be another 50 that was added up a couple months ago. It's not going to be 50, but every year I'm sure there's going to be 20 being added. Generally, I think the best chance of success against being enough compatible enough, like almost aiming for the stars and being happy with the moon. Everybody wanted SSO, single sign-on. Everybody was okay with reduced sign-on from 22 coming back to 3 was good enough. Same thing. From that 300, maybe 20 is good enough for any company. So Emma, give me that 20 and let's be done. No, for each company it's different. You should find the threat actors that are attacking you. That shouldn't be that tough. Once you find those threat actors, go to the website. Each threat actor is very good in certain techniques. Let's say threat actor A is very famous in 1, 2, 3, 4, 5 from the 300. Threat actor B, she's really good in 3, 4, and 8. If these are the threat actors targeting my organization, 3 and 4 were the common denominator. I should fix on those 2 techniques in order to cover myself 60% from 2 actors. I'm really sorry for picking on you, but so all of a sudden, just by attacking 2 techniques out of 300, you're not even 1%, but you're 60% against your threat actors. So I was in Istanbul. I have a Turkish background, so I'm being sent there as often as I can. One bank, after I finished the discussion, I didn't give this example yet. I stopped it. I said, "Are you guys doing it?" They said, "Of course we are doing it." "What are you doing?" They are taking the first tactic. Why? Because it's the initial access. If they can stop them from getting the initial access, then we will almost stop all of them. Very good approach, but not the best approach, because probably there are some actors who are already into maybe halfway into their campaign. You will never catch them if you do it that way. So it seems covering the common denominators of the special actors is the best way to stop your defenses.
And Emma does not work for MITRE, just to be clear. Yeah.
Awesome.
Thank you, Emma.
Mate.
Yeah, no problem. Any other questions? All right. Thanks, everyone.